Sometimes you have bases other than e you need to deal with. If a is a positive real number and does not equal to 1, and x is any real number, then the exponential function to the base of a is denoted by a to the x and defined by a to the x is equal to e to the log of a times x. If a is equal to 1, then y is 1 to the x, and that's 1, and that's just a constant function. Now the rules are very similar. A to the 0 is 1. A to the x divided by a to the y is a to the x minus y, so you're going to take the difference there. A to the x times a to the y is a to the x plus y. And a to the x raised to the y power is a to the x times y. Similarly, and this is the one you really need to be comfortable with, log base a of x is equal to the natural log of x divided by the natural log of a. You need to be able to do this conversion. So we know that the log base a of 1 is 0, and the log base a of x times y is the log base a of x plus the log base a of y. Well, the log base a of x to the n is n times the log base a of x, and log base a of x divided by y is log base a of x minus log base a of y. Now, we say that y is a to the x if and only if x is log base a of y, and log base a of x is equal to x for all x that are positive, and log base a of a to the x is x, because these are inverse functions. So raising log base a, making log base a the exponent of a, these kind of cancel because they're inverses. Similarly, log base a of a to the x, this is an inverse function, so this is also equal to x. Let's look at some examples. Suppose I tell you 3 to the x is equal to 81. How would I solve for x? Well, I want to get rid of 3 to the x, so I want to take the log based 3 of both sides. So this is the log base 3 of 1 over 81. Now log base 3 of 3 to the x is just x. And I'm left with log base 3 of 1 over 81. Now, let's look at what this is. This is really the log base 3, and I want to get 81 in terms of 3 if possible. And so this is 3 to the negative 4. So now I have an inverse relationship. So log base 3 of 3 to a power is just the power, and that power is negative 4. So I can say x is equal to negative 4. So I can say 3 to the negative 4 is equal to 1 over 81. What if we're working the other direction? What if I have log base 2 of x is negative 4? Then I want to make this the exponent of 2. So 2 to the log base 2 of x is equal to 2 to the negative 4. Now these are inverses, so I'm just left with the argument, which is x, is equal to 2 to the negative 4, which is 1 over 2 to the 4th. So x is 1 over 16.